thing that we are reviewing is graphing the linear inequalities. Remember, it's just like graphing a line to begin with. We start with y equals mx plus b, so what's my slope here? My slope is negative 3/5, my y-intercept is a positive 2. So we put our point at positive 2. And then how do we denote the slope from there? Down 3/5. Or if you wanted, you could go up 3 and backwards 5. I know you don't have a ruler, but I think you can do this one. Okay, and then this is the piece we had to pay attention to. What do we have to watch here? If our line will be solid or dashed. How do we know? If it has an equal to, it's solid. If it does not, it's dashed. So if it has the line underneath your inequality, that's a solid line. If it's just a less than or greater than by itself, we do a dashed line. Oh, that's a horrible line. Okay, and then we have to shade. I can't draw straight lines today, apparently. Excuse me. Sorry about that. Greater than is above, less than is below. So this one would be above. Or think, here's my y-intercept, I want it to be greater than that. So we are shading this part of the line. What's different about 26? There's 2 of them. So we do each one individually, and then our final answer is the overlap. So the first one, we graph it, y-intercept is 2, slope is 2, so up 2 over 1, or you could go down 2 and backwards 1. Solid or dashed? Dashed, because it did not have an equal to. Okay, where are we shading? Less than is below. But do this very lightly, because it's not our final answer yet. Okay, the second one. It has a y-intercept of negative 1. Slope of 1/2. So up 1 over 2, or down 1 back 2. Solid or dashed? Solid, because that one had an equal to. Alright, above or below? Less than, so that's below my y-intercept. So it's down here. Right. If you struggle, you can use colors or something. We are looking for the overlap. So this is the region that got shaded by both of them. So you darken that in. That is our final answer. Any order pair in that area makes them both true. Are we okay with the inequalities? Word problems. Let's take a look at some of those. All right, Alan has a collection of 63 nickels and quarters in his piggy bank. If the total value of the coins is $10.75, how many quarters does he have? So what did you have to do first on these? Define our variables. So the 2 things I'm looking for. And there's a question like this on our last test, and a few of you kind of struggled with it a little bit. We know we have 63 coins. So what's our first equation? X plus y. The second equation was the one that people had trouble with. The value is $10.75. What's the value of a nickel? 0.05x. A quarter. 0.25y equals to 10.75. Make sure you're watching your decimals on those. All right, now what do we do to solve this? Oh, elimination is probably the easiest. If you want to eliminate x, we would have to take the first one times negative 0. So you get negative 0.05x. minus 0.05y equals negative 3.15. Second one stayed the same. So if we add, the x's cancel. Negative 0.05 and positive 0.25 would be 0.2y equals 7.6 divide, and y equals 38. Do I actually have to find x to answer the question here? No, my question was how many quarters, and y is the number of quarters. So technically, that's all I needed. But I could have very well asked for nickels or both. So if you need to get those, you just plug it in. So your x would have been 25. So we have 25 nickels and 38 quarters here. Is that one okay? The next one is not a system of equations. We have a legal service, charges a $300 consultation fee and $250 per hour for their services. Write an equation to model the cost of hiring the legal service. What kind of line or equation is this? It's linear. What will the 300 and the 250, what are those representing? They're giving us their cost. Okay. Think about the equation of line. Y equals mx plus b. When we did these, it's been a while, but when we talked about slope, I told you that slope is always a rate. So if you're trying to find the slope in the problem, look for the repeated thing, the thing you would pay over and over again. Which of those two do you pay more than once? Yeah, the 250 per hour. That's the other thing. I told you a slope usually has a per in it. So my equation, you have to pay 250 every hour, so 250x, plus your b, the y-intercept, that's a one-time cost. What do we only pay once? The 300. So that's my equation. So the second part, what would it cost for 3.5 hours of work? What am I going to do? The x equals 3.5 or 3.5. So we plug that into our equation. So it would cost $1,175 for 3.5 hours of work. Last one. I want you guys to take a second, read it, and see if you can figure out what to do there. I gave you an equation. And it tells us, this is my cost. So C here represents the cost. What's M? The miles. If you only have $150 to spend, at most, how many miles can we drive? So what do we do? Where do we put the 150? Is it a cost or the miles? It's a cost. Can we solve this equation? We subtract our 80. So 70 divided by 0.65 comes out to be 107.69. So at most, how many miles? If I had to round this to the nearest mile, can I drive 108 miles? What's going to happen to my cost? It'll go over the 150. So the most number of miles I could drive would be 107 miles. Okay, in this case, we're not following the traditional rounding rules. We're looking at the context of the problem. If you only have 150, you can't go over. So you have to stop at the 107 miles. Any questions? All right, so the study guides that were turned in to me, I'm going to give back. I have